Okay, so today I will present about the fluid dynamics lab, which the title is Bernoulli equations. Okay, first and foremost, so I would like to discuss about the introduction part. According to the Bernoulli principle, when area available for the fluid to flow decrease, then flow velocity of the fluid increase, and at the mean time the fluid pressure or the fluid potential energy decrease. This principle was named after Daniel Bernoulli, who first writes this principle in book named Hydrodynamics. So we proceed to the next one, which is the purpose of the experiment. So the aim of this experiment is to compare the behavior of ideal fluid and real fluid. The next one is the objective. The first objective of this experiment is use the ventral meter apparatus to study the effects of area of the flow velocity and fluid pressure. The second objective of this experiment is use the Bernoulli equation to compare the behavior of ideal and real fluid. We proceed to the theory. So according to the Miller, so the law of conservation of energy was the main deriving factor behind the derivation of the Bernoulli principle. The Bernoulli principle stated that in a steady flowing fluid, the sum of all the mechanical energies, including kinetic energy, dynamic head, fluid pressure, and potential energy, should remain same at all the point of the flow. So if any type of energy increases, like if kinetic energy increase, then the other type of the energy, like potential energy, pressure, will decrease to make the final sum same as before. Let's proceed to the next one. So according to the Bernoulli equation, a flowing fluid might have three things. The first thing is the pressure head, the second thing is the kinetic energy, and the last thing is the potential energy. The next one is the discuss about the Bernoulli equations. Okay, so in this picture, if a section of the pipe is as shown as before, so this one is the Bernoulli equations, where in SI unit, the P represents the static pressure of fluid at the cross section. The second one is the density of the flowing fluid in, and the G means the small capital of G represent the acceleration due to gravity. So the V represent the velocity of fluid flow at the cross section. The H represent the elevation head of the center of the cross section with respect to a datum. So in this experiment, we might have to use some of the apparatus. The first apparatus is the arrangement of ventral meter apparatus. The next one is a hydraulic bench. The next one is the stopwatch. The next one is the procedure. The first procedure is note down the inlet, the throat, and outlet section areas. Measure the distance of inlet, throat, and outlet section from origin. Then we have to switch on the motor attached to hydraulic bench. Next, if there any water bubbles is present in tube, remove it by using air bleed screw. The next one is we have to fully open the control valve. So after that, we have to note down the reading piezometer corresponding to the sections simultaneously. Note down the time required to a constant rise of water in volumetric tank. Okay, so the last procedure is wearing the discharge and take at least 6 readings. So this one is the experiment results, and following by this one, and also this one. After the experiment result, we have generated some of the graph. So this 3 graph is the graph that we generate from the experiment. So let's move to the next one. The next one is the discussions according to the graph. So from the calculation, it's very clear that with decrease in area of the flow, velocity increase and pressure decrease. As shown in graph, all 3 tests, that the decrease in area of flow decrease the head of water in manometer column, meaning that they are directly proportional to each other. So the third discussion we can get is the difference in the theoretical and measured value. It can be said that water is not an ideal fluid. Last but not least, the head of water in the final column was not equal to the initial value, which shows that there are friction losses in water particles. The last discussion is that This type of information is very useful in the case if nozzles, jet and diffuser. Let's come to my last part of my lab report. So the last part is conclusion. So M objective of this experiment was to discuss the behavior of ideal and real fluid, and on the basis of the test result it can be concluded that the experiment was successful because there is difference in measured and theoretical value. This is because of the frictions losses in the real fluid. Ideal fluid doesn't have friction losses. So from this experiment it can be concluded that with decrease in area of flow, there is an increase in velocity and decrease in the flow pressure of the fluid. That's all from me. Thank you.